Hello everyone, welcome back to the one more session of multimedia systems. So let us continue our discussion with the topic called the data compression. Let us recall what we had discussed in the previous session. In the previous session, we had discussed about the hierarchical mode of compression. So the advantage and the various techniques in association with the hierarchical mode. So and we have also discussed with respect to H261 compression and also H263 compression. So we have also seen the difference between the H261 and also H263 compression. We have seen the two picture video format, that is CIF and QCIF, and we have extended our discussion with respect to H261 compression, which includes a combination of various techniques like the interpicture prediction, transformation coding and motion vectors. We have seen this in detail, and also we have discussed about the H261 compression detailed design with respect to prediction, block transformation, the quantization and also the entropy coding. And we have seen the advantages and disadvantages of this compression technique. Today we will extend our discussion with respect to the Mpeg. When we talk about the Mpeg, we know what is Mpeg, that is Motion Picture Experts Group. Till now, we had discussed about the compression with respect to only the still images and only with respect to H.261 and H.263. We have seen a bit of compression in association with the still images plus the motion pictures. So let us recall all the concepts of H2.61 and H263 completely and continue our discussion with respect to Mpeg. When I talk about an Mpeg compression, it includes two. One is the audio plus the video, that is the motion picture. Here, whereas in a JPEG and other compression, we were talking only about the still images. But now, when we talk about the Mpeg, we are about to compress two components. One is the audio component and second one is the video component. So, when we talk about the compression, if this is the data stream, whereas an Mpeg consists of two, that is the audio plus video. When we wanted to compress, the audio will be compressed into MP3 format. This is very important. Whereas the video needs to be compressed MP4 format or Mpeg formats. So whatever the format it is, so we need to concentrate on two kinds of component compression. One, that is the audio, and second one is the video component. Now let us look into the Mpeg directly. When we talk about an Mpeg, it was developed and defined by ISO and IEC. So this is very important when you talk about ISO and IEC. So these are the two main standards which was able to generate the specifications of Mpeg compression format and came up. So when you talk about the Mpeg, it is not that only one company, there was several organizations, the companies involved with respect to the Mpeg format. So we also know that it was called the Work Group 11. And they call it as WG11, which means work group 11, means 11 different organizations involved in the component of deriving the standards for the Mpeg compression. Though when you talk about the Mpeg, it is a lossy compression, you know that. It comes under the category of lossy. So it was defined by ISO and IEC standard. The main goal of the compression with respect to Mpeg was to compress the data stream at the rate of about 1.2 megabits per second. So this was the main intention. So in order to achieve 1.2 megabits of compression rate of data stream was the main intention of ISO and IEC things. And Mpeg specification as a maximum data rate of, so this is very important, we need to consider. $15,600 bits per second. This is the data rate that needs to be achieved, and they are able to achieve it. So one more thing, when we talk about the data rate of each audio channel can be chosen between 32 and 448. This is important. Kilobit per second. So what is that? Audio data rate. So they were able to come out, because this is very interesting. This data rate enables video and audio compression for an acceptable quality, means so the satisfactionable or desirable quantity of data rate is between 32 to 448 kilobits. This is been achieved with respect to Mpeg. Since 1993, Mpeg has been associated or recognized as international standard from 1993. This is the key point we need to consider, means from 1993 itself, with respect to the audio plus video kind of component, Mpeg is considered to be the international standard. Now when we talk about the Mpeg itself, the Mpeg explicitly takes into account the development in order to standardize activities. So why it is considered? Because when we talk about an Mpeg, before the specification of Mpeg was released or generated, there had two more components of compression. The for still images we had a JPEG compression, and for the motion pictures or in association with the motion image pictures we had H.261. So all these standards need to be associated or to be considered in order to have the compatibility issues. Okay, because if a new standard was brought, there needs to be facing lot of compatibility issues. So these previous standards and some of the specification needs to be considered in order to continue the compression into a new standard. So what are the two things that Mpeg is explicitly associated? Mpeg is totally associated with the consideration of two standards that was already available. The one was JPEG and other was H.261. So those two, I don't say that every specification of JPEG and H.261 considered. Some of the feasible standards and the methods and the technology was derived from a JPEG and also from H.261 in order to frame the standards with respect to the Mpeg. When we talk about JPEG, video sequence can be regarded as a sequential of still images, and JPEG standards development was always ahead of Mpeg standards. This is, we know that because we have already seen the JPEG compression technique. It was way back invented before the Mpeg became a standardization in 1993. So Mpeg standard make use of the results of the JPEG work, means most of the specification, the working principles and some of the standards of JPEG was also derived in order to define the specification of the Mpeg. And then about the H.261, it is an already existed, because with the H.261 we were able to compress the videos with low data rate. We have seen this in the previous session. Okay, merits and demerits we have also come across with respect to H.261. So H.2.261 was already existing standard. During the Mpeg work, the Mpeg group derived to achieve a least or a certain compatibility between the two standards in some areas. So between these two standards, Mpeg also derived some of the standards in achieving its own specification. So this property helped to overcome the compatibility issues with respect to Mpeg in the future. This was about the Mpeg. When we talk about the few components of Mpeg, we need to understand the concept of frames. We need to know the word frames. What are those? A motion picture consists of sequences of frames, or the sequence of still images consecutively loaded or in a sequence of still pictures together is said to be a frames. So each still picture is said to be a single frame. So these pictures are in a continuous motion generates a moving picture. We have already come across these things. So how many types of frames are there? So what are those? When I talk about frames, we need to look into the four main types of frames. One is the I, P, B, and to some extent the D also. There are three main plus one more type of component, that is the fourth one, frame, that is the I, B, P and D frames. We need to look into it. Let us look into that with the help of a diagram. Now, this one is an I frame. This is a B frame. So I'll draw one more B frame. So I, B and B. Now what happens? I'll write a P frame. After the P, again the sequence of 2 will be there or more. I'll represent it as B, B, and at the end even there would be P, and next I. So we see a sequence of frames being represented. So when we talk about the sequence of frame, I is associated from here to here. I will tell you when we talk about the frames individually. So here I is representing this axis and P to the next pertaining frame, and this is totally said to be the time axis. So over a period of time we encounter I, BB, P, BB, and continuously it goes on to some extent. So we can make it as a dotted line, means it represents there are a lot of other frames. So just for the convenient, I have drawn only the required amount of frames, and then the P, and there might be some more frames, the P and I frame. So let us look into the details of each kind of frame. When we talk about the I frames, first we'll go with this. When we talk about I frames, it is called intra-coded pictures. Means here it is associated with what kind of pictures? intra-coded pictures. So iframes are coded without using the information about the other frames. Means, look at this. This iframe is formed, or this iframe is present without using any information from the previous frames. Means this iframe is totally independent frame. Sometimes in some of the books it is also referred to as, or by during the explanation, some of the author directly explains the iframes also as independent frames. Means this frame is totally independent, or it is not using the information about other frames. So that's why it is referred to as intra-frame coding. Intra-frame coding. So an iframe is treated as a still image. Look at this. This is still image. Yes, of course, because this is the first one in the sequence to be generated. Means from 0 to something has been generated. It is not continued with some other things. So it is the first frame. So it is said to be an independent still image. Here when we talk about Mpeg, it falls back on the results of JPEG, because we are using a still here, still image. That's why we are using the compression technique that are also associated with the JPEG also. You might be asking, sir, why do we need to have the standards of JPEG and also H2.61? Now the requirement of still image compression technique comes into picture, because this is an independent frame. It has not been derived from any other previous frame, or no information is derived. So it can be considered, or it can be treated as a still image itself. So that's why some of the characteristics of JPEG has been derived here. Unlike JPEG, the real-time compression must be possible here. The compression rate is thus lowest with the JPEG in association with respect to the Mpeg here, because here we are using the iframes which are independent. That's why we see a low compression rate. Iframes form the anchors with respect to the random axis. Means here it might be used as a random pictures with respect to the axis. This is about the iframes. When we talk about the preframes, it's the second one. What is this preframe? What kind of images are associated with the preframe? It is predictive coded picture. These preframes are directly associated with the predictive coded pictures. What we see, let us concentrate here. When we talk about preframes, these preframes require information about the previous iframes or the preframes itself. Look at this. Here, preframes are there. When we talk about the preframes, it requires the information from the previous iframes or the preframes. Means these frames require the information from the previous one. Means here what might be the previous one, we are predicting it. That's why we call this concept as predictive coded pictures. So what is this prediction needed? This prediction is mainly needed for encoding and the decoding concepts. When we talk about a decoding of p-frame, it requires decompression for at least or for the last iframe. Means when I talk about the decompression of p-frame, it needs to know that when you talk about decompression, which was the previous iframe. That's why there is a link. It is always refers the previous thing, which is the iframe. When you talk about the iframe here, previous this one, so how did we get? So there are lot of B frames. So we predict what kind of frames might be there in between the P and the I. So that's why we call it as the predictive, the coded pictures. So in turn, the compression rate is considerably high than the iframes here, and a pre-frame, a single p-frame allows the following p-frames to access if there is no interleaving iframes. Means if there is no interleaving, means if there is no b-frames in between, it is also capable of accessing directly the iframes. So this was about the p-frames. Next we look into the b-frames. So here when you talk of B-frames, what kind of pictures are associated? Here it is directly associated with bidirectional predictive coded pictures. So you look at this, B-frames are just predictive coded pictures, whereas B stands for bidirectional, means both the direction with respect to previous and also with respect to the future. Bidirectional predictive coded pictures. So these B frames require information from the previous. Look at this. You can see always a B frames is directly associated with some of the B frames and also at the previous and also some of the B frame in the future appearance. See, look at this. With this there might be or there might not be, but here there is a future B frame, but here in this case there is a B frame in the previous frame itself. So this is called a bidirectional activities. So following which can be followed by the I frame or a P frame. So it can be associated with either a B frame or a P frame. So both the things can be looked here. See here, a B frame is followed, okay, or in future, in front, in association there is a P frame, whereas in this case it is being followed by an I frame. So B frames are bidirectional. It should be always having one of the successive or a preceding another frame which should be a B frame, or it can be followed by a I frame or succeeded by a P frame. This is the main intention. B frame yields the highest compression ratio attainable in Mpeg. So from with respect to I and P, B frames can be achieved with respect to highest compression because there is a lot of elements in order to compress the exact data, the previous and the future. So we can predict it, we can compress it. When we decompress it, those prediction can be applied and a new stream of data stream can be achieved. That is why we have high rate of data compression with respect to B frames. When a B frame is defined as a difference from a prediction based on a previous or a followed Mpeg or a P frame. What I said exactly means it is directly followed or a prediction done based on either I or a P frame. So it cannot be, however, serve as a reference of prediction with respect to coding of other pictures. So this point should be kept very clear. These frames cannot be used as a reference point because these are the intermediate streams, whereas this is a still image which can be considered as a reference point, that is the I frame. So these B frames cannot be considered as a reference point because there might be n number of B frames in between. So they vary, so it should not be taken as a reference point. Next is a D frames. When we talk about the D frames, these are DC coded pictures. In one of the session, I have already cleared the components with respect to the DC, where DC coded component, that is DC coefficients with respect to sound and the video has been clearly clarified. So when we talk about the D frames, these are intra-frame coded. means in between the frames, between, inside is being coded and can be used for efficient fast forward. Means in order to have the fast forward technique, in order to move directly from one state to another frame state. So during this, that is D frame, the DCT, the only DC coefficients are coded, then the AC coefficients are ignored. So in order to have the fast forward concept, so we use these kind of DC frames or coefficient, that is we call it as D frames. So these were the concepts with respect to the frames. So that is the I frame, P frame, B frame and D frame. So D frames are very less or seldomly discussed. Next, we'll continue our topic with respect to the audio coding. When we talk about audio coding, here we are mainly concentrating audio coding with respect to Mpeg. So it is a compatible, okay, with the coding of audio used with respect to CDDA and DAT techniques. Means here the audio coding technique is totally compatible with respect to CDDA and DAT technique. So these two technique and its working principle we have seen in the optical storage chapter. It is important to know the criteria is the choice of sampling rate. Means the main concept behind the audio coding is the choice of the sampling rate. So what is the choice of with respect to the sampling rate? (44.1 kilobit per second). So here they are mainly concentrating with respect to 44.1 kilobits per second of data transfer. With the sampling rate, it can also extend to 48.1, sorry, it's a hertz, kilohertz, because we are talking about the sampling rate with respect to audio. So when you talk about audio, it is always the hertz or a cycle per seconds the unit. Those units needs to be used, and we are making use of, when you talk about audio, you are using about the 8-bit sampling, that is 8-bit quantization. Here, even with respect to the CD-ROM 1, CD-ROM mode 2, we have seen the 8 to 16-bit modulation. When we come out the discussion with respect to the DVD, we have seen, we have encountered with the 16-bit modulation. Here, it's the same with the audio also, because we are using a combination of audio along with the video. So we use 16 bits per sample. That's the sample rate, and each audio signal is compressed either to 64 or 128 or 192 kilobits per second. Means the audio which is being used here in this technique with respect to Mpeg is compressed either for 64-bit or 96 or 128 or 192 kilobits per second. So when we have this audio technique, there are three main levels that needs to be considered, and sometimes they also refer to as the 3 layers of audio coding with respect to the Mpeg. So what are these 3 layers differ? These 3 layers mainly differ with the encoding and the decoding complexity that has been implemented during the process. And with the similar to 2D DCT for video, the transformation into frequency domain is applied for audio also. So So in the video we have seen that is a two-dimensional discrete cosine transformation is applied. The same concept is also applicable for the audio. And one more thing that needs to be considered here is we use FFT. Earlier we have seen only about FT, that is Fourier transformation. Here this technique is used. What is that? FFT, fast Fourier transformation, is very much suitable with respect to the audio coding of Mpeg. Let us discuss this concept with the help of a diagram. So first we need to talk about the uncompressed audio signal. Initially, an uncompressed audio signal is obtained and which serves as an input. Now the uncompressed audio signal needs to be fed or pushed into a process called process where this signal is totally, a division is made in 32 frequency bands. Now we divide into a division process is done with respect to 32 frequency bands. Okay, means this audio compression, uncompressed audio, is totally divided with respect to 32 bands. Why is that? We'll see. And also psychoacoustic model is associated with that. So why is this? Directly psychoacoustic model is also used. Why? In order to have the control. When do we need to have the control with respect to the psychoacoustic signals? Is during the process of quantization. So these divided 32 frames are fed into the process of quantization and the controls are also provided here. So what comes here? The 32 bands. So finally we apply, if needed, we apply the entropy encoding. So what is the output? Finally, after all the process, we get compressed audio data. So this is about the Mpeg audio compression. So we'll look into it. So initially when we talk about the Mpeg audio compression, first the uncompressed audio signals are obtained. These audio signals are split into 32 sub bands. Mean this audio signal, you know that always the audio signal can be quantized because we need to separate the signal. So here we are specifically saying 32 sub bands needs to be done. So here in this process we divide the spectrum of sound signal into a separate 32 sub bands. So different components of the spectrum can then be quantized differently. Means there are different frequency ranges, so it needs to be quantized. So this is the reason we do a separation of 32 subband. In parallel with the actual FTT, that is fast Fourier transformation, the noise level in each subband is determined using the psychoacoustic. See, when we talk about the sound, the noise would be intruded without the knowledge. So this kind of noise can be determined with the psychoacoustic model. So what is exactly the causing the noise? in the audio, what are the other noises. In order to derive those things, we need to have one more process with parallel to the division of the audio signal. We call it as where the FFT is applied and those signals or information or controls are given or fed before the quantization. So higher noise levels, a coarse quantization is performed. COARSC, coarse quantization is done. For lower noise level, the results is finally a finer quantization. No need to worry. So in the first and the second layer, the appropriately the quantized spectrum components are simply the pulse coded modulation, means the PCM encoding is done. And in the third layer, additional performance means here if you need any kind of additional performance, or you can use the entropy encoding, that is the Huffman coding and other things can be used. So when you again extend the things with respect to audio coding can be performed both on the stereo sound and the mono sound. When you call about a stereo, it is two channel. There are two components. One is mono and stereo. In the mono we have single channel, whereas in the stereo we have two channels. This audio coding or compression technique also supports the mono as well as the stereo channel, that is two channels also. Mpeg provides two types of stereo sounds. This is very important. In the first case, two channels are proceeded completely independently, means in the case one, stereo itself there are two properties. In the first one, the two channels are processed completely independently, means separate different channels. That's why you might see sometimes when you use an earphones, the left and the right, you will be hearing voice at the one earbuds, earphones very low and one of the earphone very high, because there is a compression with two channels separately. In some other cases, you use equal amount of sound level at the both the earphones. So it is not the fault of the earphones or the headphones, it is the compression technique that's been deployed there. So this is about the audio coding. So when I talk about all the things what we have discussed today, let us summarize it. We have discussed about the one more lossy technique, that is the Mpeg. The importance of Mpeg was discussed, where we compress both audio and the video. But in this session we have totally discussed about the audio concept, and we have also looked into the concepts of frames, because when we talk about the audio coding and also video coding, we directly use the terminologies called the frames, that is Iframes, B-frames and D-frame. So these components were made clear, and we have also discussed about the audio coding, that is the help of a coding diagram. So how the audio is totally compressed with respect to Mpeg technology. These are the topics I had wished to discuss in this session. Thank you very much.